Okay, so in yesterday's lesson we talked about imaginary numbers, and today we're going to build on that and talk about complex numbers. Now, if you don't have my notes, rather than having to write down all of this, what I would encourage you to do is write down what I've highlighted over here on the right, because this pretty much sums up what we're getting at in this first quarter of a page here, this first couple of paragraphs. This illustrates what a complex number is. Basically, a complex number is made up of a pure imaginary number like 2i, that's what we looked at yesterday. So pure imaginary numbers would be like negative 6i, 7i, 4i, 1/3 I. Those would all be pure imaginary numbers, where the I is your imaginary number. If I have a real number times that, it would be called or classified a pure imaginary number. So that's what the 2i represents. The 6 is just a regular old real number. Now if I add or subtract a real number from a pure imaginary number, I call this a complex number. So the definition of this would be a complex number. So 6 plus 2i would be a complex number. Negative 5 minus 3i would be a complex number. So anytime we have a real number and we're adding or subtracting from that in a pure imaginary number, it's classified as a complex number. That's what this whole paragraph is about. And it's reminding us here too about the fact that in an imaginary number, I represents the square root of negative 1. So now all the operations of adding, subtracting, multiplying, and dividing of real numbers apply to complex numbers. That's what we're going to be looking at for this lesson. So let's look at a couple of examples dealing with addition. These are real simple. Adding, so just involves, well, first off, if we don't have anything outside of the parentheses to distribute, we just add these normally. So we add together our like terms. So 2 plus the 6 would give me 8. 3i plus the 9i would give me 12i, so my answer here would just be 8 plus 12i. We can't add those together because they're not like terms, just like 8 plus 12x would have remained like that. These would remain as separate items, 8 plus 12i. Let's say if I have subtraction. If we have subtraction, that's a little bit more difficult, because that involves we have to distribute this negative through to everything inside the parentheses. Now this first set of parentheses I really don't need. I can just write this as 4 minus 3i. Because there's nothing outside the parentheses to distribute. That's why I don't need it. But then minus is outside the parentheses in the second set, so I'm going to distribute that minus. So it's minus 6 minus 5i. Now I add together my like terms. So my like terms are the 4 and the minus 6, so that's going to be negative 2. Negative 3i minus 5i would be minus 8i. Because if you have negative 3i and you combine that to negative 5i's, it's going to get further negative, so it's going to be negative 8i. Let's look at one more. Let's look at this last one. If I have 8 minus 4i minus 1 minus I, I'm going to start by distributing the negative through. So it'll be 8 minus 4i. Distribute the negative, so it'll be negative 1 plus I. Well now, when I combine like terms, 8 minus 7, 8 minus 1 is 7, and negative 4i plus I would be negative 3i. And that's all we do for these. Pretty basic. Just remember if you have a negative outside the parentheses to distribute and then add like terms. Speaking of distributing, let's look at these. So here I'm going to have to distribute the 4i times the 8 plus 5i. Now remember, we need to recall from the previous lesson that anytime we have I squared, we need to simplify that because I squared is the same as negative 1. So when I distribute 4i through here, I get, well, 4i times 8 is 32i, and 4i times 5 is 20i squared. But remember, I squared is negative 1, so this is really 32i minus 20. Because if I squared is negative 1, multiply that times 20, that gives you negative 20. So our answer is 32i minus 20. Now notice how it says to write your answer in a plus bi form. This is a common form that we want to write our answers when we're dealing with complex numbers, where our imaginary number would come second and our real number comes first. So for this particular answer, this is a negative 20, so I'm going to write that first, negative 20. That's a positive 32i, so I'm going to write it as 30 plus 32i. That would be your final answer. So I always want to make sure that you arrange these to be in the proper order, to be in a plus bi form. Okay guys, why don't you guys take a minute to work on this next one, where we're going to distribute 7i through to this 9 minus 6i. So why don't you guys go ahead, pause the video, and hit play when you're ready to check your answer. Okay, so What you should have done here is you should have distributed the 7i through. When you do that, you get 63i minus 42i squared. Remember, I squared is the same as negative 1, so negative 42 times negative 1 would make that a plus 42. We want to put this in the right order, though, so instead of 63i plus 42, we would write this as 42 plus 63i, and that would be your final answer. Okay, so now, again, we're just going to get gradually more and more difficult. We're going to add more and more pieces. Let's look at these next couple of problems. Here we're going to FOIL. We're going to multiply 6 minus 2i. We're going to take this binomial times this one, 4 plus 3i. Now what we want to do here is you can either FOIL these or we can use that window method that I've showed you. So with the window method, I would take 6 minus 2i times 4 plus 3i. The nice thing about using this method is it keeps our numbers organized. And when we go to simplify it, you'll see that something happens here that makes it also easier to use this method. So when I multiply these together, 4 times 6 is 24, and 4 times negative 2 is negative 8i. And here 3i times 6 is 18, so I have 18i, and 3i times negative 2i is negative 6i squared. But remember, I squared is equal to negative 1. So in this box where I have negative 6 times I squared, well, negative 6 times negative 1, negative 6 times negative 1 would be a positive 6. So now I want to put these in a plus bi form. So to do that, I would add my like terms. Well, 24 and 6, if you notice, are diagonally across from each other. 24 and 6 give me 30. And if I add together my other like terms, they're also diagonally across from each other. 18i minus 8i gives me 10i. And this is in a plus bi form, so my answer would be 30 plus 10i. Okay, why don't you guys take a minute now and work on this next problem. We're going to multiply 5 plus 7i times 6 minus 2i. So why don't you pause this video and hit play when you're ready to check your answers. Okay, so what we should have done here is we should have, if we use the window method, we'd set it up like this, where it would be 5 plus 7i and 6 minus 2i. Don't forget your pluses and minuses in there. That makes it important. So 6 times 5 is 30. 6 times 7 is 42, so it's 42i. Negative 2i times 5 is negative 10i. And this would be negative 14i squared. Again, the negative 14i squared is the same as negative 14 times negative 1, which gives me a positive 14. So when I add together my like terms for this one, I would get, well, 30 plus 14 is 44. And 42i minus 10i is 32i. So this would be plus 32i. And there's my answer.